Okay, it's my absolute pleasure to introduce our next speaker. No one would argue with me that the Mars Desert Research Station is the heart and soul of the Mars Society, and so is Dr. Shannon Rupert. She is an ecologist with 2 decades of experience in Mars analog studies and an expert in planetary mission simulations and field exploration. Formerly a professor of biology and environmental science, she was currently the director of our Mars Desert Research Station in Hanksville, Utah. Please welcome Dr. Rupert.
So when I realized I had a half an hour to give a talk on what I've done for the past 20 years, struggled with that a lot. Actually got here, still had no idea what I was going to talk about. And then I realized I had to cut it into pieces. I simply just did not have enough time. Since my whole heart and soul is analog missions, but it's not yours, I thought I would kind of let you know the categorization and classifications of analog missions. As an ecologist, I studied patterns, so I like putting things into boxes in here. So that's where we're going to start. So for those of you who don't know, the analog research world has exploded, and we currently have this worldwide network of both Mars and Moon analog sites around the world. Everybody does things a little differently, which is great because that all contributes to the body of knowledge that will get humans to Mars. But I wonder how many people are not even aware of really what an analog is. And so I thought I'd start with that. There are a bunch of different Martian environmental constraints that you want to look for in your Mars analog sites. But early on, actually before Pathfinder, we just said, hey, that looks like something that we saw on Viking. And so our ideas about what Mars analog site were based on what things look like. And if you go back 20 years, even though we had data from Pathfinder, when we chose MDRS site, we actually chose it basically for that reason. Serendipitously, it turned out that over time and with more data that came back from the robotic missions, we learned that, hey, not only does this look like Mars, it has the same processes and the same structures as geologically as we see on Mars. So MDRS is, in fact, a true geologic Mars analog. And we didn't actually know that at the time it was chosen. Every single Mars analog is limited because it's not going to have every single environmental factor, right? And so you have to, when doing research, you have to make assumptions about those constraints, which fortunately, for a lot of different disciplines, including ecology, we're really happy to make assumptions. We're very good at that. So there are 3 different categories of Mars analogs. There are research stations, there are simulation programs, and there are analog environments. Some of Carol's photos in the Atacama showed what an analog environment looks like when humans go out without spacesuits and they do research that's going to be applicable to what we know about Mars or want to learn about Mars. Research stations, on the other hand, have permanent structures that are generally based or hope to be based on some sort of Mars mission architecture. Hence, when we first put FMARS and MDRS up, those tuna cans are actual spacecraft from Mars Direct. So we actually have a spacecraft that could go to Mars, which always fascinates people. They're like, really, that could be flown? And I explained to them how, and it's usually pretty exciting. Most research stations that have permanent architecture, permanent structures, do full simulations, meaning that those people who are doing, that are the researchers that are there are acting on as many constraints as they would have on a Mars mission as possible. We'll talk about the different types of simulations in a little bit. Simulation programs are those that are may have a temporary structure erected, for also based on mission architecture more generally. Some of them are quite spectacular. Amadi would be a great example of a simulation program where every 2 years they go to a different place and they put an amazing facility up for just a month, and then it disappears. These are generally semi-sims because there's a lot more research going on. They have outdoor external researchers that come in and maybe will spend a week looking at spacesuit design. And so if you look at pictures of these simulation programs, sometimes you'll be like, why are there 2 people in suits and 15 people outside taking pictures and notes of them? That's what happens when you do a semi-simulation. I use the term semi-sim. I don't know what other people use, but it's just the easiest way for me to describe it. Analog environments, generally no structures. Researchers come in, do the work. They're looking for answers to scientific questions about Mars. More generally these days, it's biology, but also geology. So a lot of field work happens. So in looking at types of simulations, a lot of people, I'm asked a lot about MDRS. So how do you simulate gravity? How do you, is the structure airtight? No, MDRS is an operational analog. We would need so much more money in order to do anything technological. So we have small technology projects, but for the most part, overall, we're looking at how do you live on Mars? What is needed? How does you work on Mars? How do you do field science on Mars? How do you communicate with other researchers when you're the only biologist on a planet and you need the help to understand what's going on? Because no biologist that I know, because I do know a couple that could go to Mars and figure it out by themselves. But for most of us, we're going to need backup when we get there, right? So technological analogs are generally much more costly to run. An example would be, we've had a few years where the Canadian Space Agency, the UK Space Agency, the German Space Agency came out to MDRS and spent a month with their rovers, running their actual Martian rovers on the analog terrain. They spend millions to come for a month. If I had millions, what we could do over a lifetime would be amazing. But it's very, very, very expensive to do technological analogs. And that's also things like how do you drill on Mars? That's less expensive than coming out and running a rover, but those space agencies still come and do that as well. They practice those things. There are analog programs that do both. They're addressing the smaller technologies, not the very expensive ones, but they still have much more dazzling and sexy things than we do. So some examples of analog research stations are FMARS, which was the very first, right? Everybody knows that, right? We have to bring that up. That's on Devon Island in the Canadian Arctic. MDRS, my home out in the Utah desert. DMARS, which is in Israel. NEMO, which is a NASA facility in Florida, is underwater. High Seas, which is now a moon analog in Hawaii. It's near lava tubes. HERA in Texas, which is basically a human factors and technology NASA facility. And the Institute of Biomedical Research in Russia, which has a facility and does a lot of biomedical, obviously, because it's in their title, work. But these are full simulations where once you're in there, when your program starts, you're on Mars, effectively on Mars. Semi-sim projects, those Mars analog semi-sims, Hot and Mars on Devon Island, which doesn't run as much anymore, but it was one of the first semi-sim type of projects. Amadi in the Austrian Space Forum. This is a program that runs 1 month they're working on their missions all the time, but they physically have a mission 1 month every 2 years. It's going to be in Israel in 2020. Mars Oz in Australia, which is one of the original Mars Society projects, has no station yet just because of funding, but we've been doing a lot of work there in the past couple of decades. Desert Rats is another example. It's a NASA project. And more importantly to me, as a human spaceflight fan, the Apollo program did semi-sim. And this is actually a picture from two of the crew of Apollo 15. I like to say when people say we're playing, what's the use of us playing Spaceman? I like to point out the Apollo program. I think it's really important to understand that what we do may seem unimportant, but it's paving the way for something that's really important. Analog environments, the Atacama, we already talked about that. McMurdo Dry Valleys in Antarctica, the Mojave Desert, there's a lot of work done out there. Rio Tinto in Spain, Axel Heiberg Island in the Arctic. Actually, there's quite a bit of work. Svalbard, I think I left it off the list, only because I just forgot to put it on there. And a ton of work in caves, variety of different kind of lakes, and in mines, deep mines, which you will never get me into. Okay, I think this is an Atacama picture. So when you're talking about a timeline, because I did say 20 years on Mars, so I have to give you some time, a perspective. The Apollo semi-sim was in the 60s. And then in the late 1980s, we had Biosphere 2. How many people have been there? Seriously, it's very, very cool. It was not a failed experiment, even though people say it was, because in science, when you fail, you also learn things. The only problem with it as a scientific experiment is it's not reproducible. Nobody's ever going to have the money to make another one. But now you can actually walk all the way through the thing. I used to sneak into parts we weren't allowed in. I just think I put that on some sort of, but I really find it a fascinating and inspirational story about what we think about all the time as analog scientists. So again, in terms of the Mars Society, in the late 1990s, we proposed these 4 stations. The first was FMars, which was built in 2000 and operational in 2001. At the same time, MDRS was built and started operations in 2001. Mars Oz was designed in 2001. It's a biconic lander, so it's different than what the other 2 stations look like. It's much higher fidelity in terms of the technology, which is why it's never been built, because nobody's going to fund it. It's quite expensive. But it's been operational since 2003, so we've been doing work there, but more like the analog environment work than any, and some semi-sim. And EuroMars, the 4th station was built, but it was never deployed. It was supposed to go to Iceland. So after a while, we got more and more stations around the world, those ones that I just talked about, which is really kind of cool. So where do I fit in this story? Because I always am stunned that I'm here. This was not the plan at all. I didn't see the moon landing. I know a lot of people are like, I've been inspired by space since I saw the moon landing and I became an engineer. And I'm like, no, I'm just an ecologist, and I'm a freshwater ecologist. Kind of weird. So I didn't have the advantage of a higher education, at least early on. I started college when I was 30. But I did grow up where I gained a huge affinity for night skies. I loved Aurora so much that my daughter's name is Aurora. I'm a meteor. I don't miss a meteor shower if the skies are clear, and I love just walking out in moonlight. What really turned me on to Mars was Pathfinder. I was working in San Diego, and I had this great big giant screen in my lab, and I started just watching Pathfinder every single day because it was broadcast. And then I was doing my grad work up above Boulder on Niwot Ridge, and if you guys have ever been there, you know it's kind of like not the hub of excitement. And somebody gave me a book called Mars by Ben Bova, and I went down to the lab, and I Googled Mars. This is way back in the day, 1999, and the Mars Society popped up. And I read about the research station programs, and I'm like, oh man, the whole idea that they're going to do this whole thing. It's like science and vision. I love it. I love it. And I just wanted to be on a crew. Don't we all start that way? I just wanted to be on a crew. So Bill Clancy said the whole story about MDRS and the HAB is, if you build it, they will come. And that's certainly true, because a number of people who've been affected by coming to MDRS, and I'm a great example, I'm like the weirdest example, was basically that idea of science and vision, right? So early on, there was a lot of, even my mom is like, are you sure you don't belong to a cult? And so she was convinced that something was going to happen. The aliens were going to come and take me away. Now, no matter where I go, it's like, my daughter's the director of the Mars Desert Research Station. So we've become very mainstream. And Lucinda and I were talking about back in the day when we were so on the edge of, people thought we were nuts, right? And to now have come into this over 20 years where it's now everybody's excited about Mars, not just a fringe group of weirdos, of which I'm one, so I'm not like saying anything bad. John Stone is another one. And, but I never expected that I would end up spending all this time at MDRS. And people say, why are you there? And I don't know. All I know is it was an inspiration to me, and it just has really, really become my life. And I'm very grateful to everyone in this room who pushed towards getting it there, and especially to Robert, who gave me the chance to take the dream and run with it. And I didn't have enough time to tell you the whole story about all the stuff I've done, but here's some fun stuff that I've done that I never, ever believed that I would ever get a chance to. And after I wrote this slide, I was like, dang, it just seems like a lot of work. But when work is your life, it doesn't seem like that. And I've had so many exciting adventures and met so damn many fine people that it's been a joy what I've been doing all this time. So I figured you guys should get something special for having to listen to me, right? So you've seen all these dramatic pictures of MDRS, how beautiful it is. Prepare yourselves. This is where I live. I thought everybody should get a chance to see where I live. This is my home on Mars. It's hidden from the station. I hide from them when they're in simulation. And with the exception of a loudmouth dog that sometimes won't shut up, I think I do a pretty good job of it. Wanted to show you also, that's the view out my living room window. I wake up every morning to that. Not a bad gig, if you can get it. And finally, I think, oh, you pretend like you didn't see that. That was not for your eyes. I just wanted to say thank you. This is a picture of the Mars 160 crew. Anastasia and I think, are the only two that are here. This is playing with the Canadian rover when the Canadian Space Agency was at MDRS. Because I've also got to play with a lot of robots and rovers. Thank you. Those are your questions. Okay, question.
Hi, how do you feel about a 3D printer printing a foundation for a HAB, and when the astronauts arrive, they could assemble it so you could get maybe thousands of square feet of HAB space rather than hundreds?
I don't
Kind of
think
like how Mark Watney had to assemble his airlock after he blew it up using plastic and
I
duct
think
tape.
you and I are probably in the same, thinking the same way. It seems like such a huge challenge and a weird challenge, and why not use in situ resources, which is more what I would, but I guess I'm a Luddite, I don't know. We have a lot of 3D printing that goes on at MDRS. It's generally biomedical and not structural, although we would welcome people who wanted to do structural work. For me personally, having watched crews destroy one 3D printer, if anybody has one they want to donate, let me know. I promise not to let them destroy the next one. I don't see it, but that's, I can't see a 1,000-person colony on Mars, because in my heart, MDRS is the end all of Mars. You know, we're on the planet, we're seeing it with human eyes, and it's up to you, everybody else out here, to take it beyond where I can take it, because I guess I just have limited vision. But I think 3D printing is promising, but I'm not sure it's as promising as, but maybe, I don't know. I don't know a lot. So, yes.
Hi, Shannon, is that right?
Yeah.
Well, my name's Bill Gardner, and I've been an environmental scientist for 43 years, so I have a great deal of sympathy for your choice of career. And and now I'm involved with some Mars analog missions. What's your impression of the preparation of people, health-wise, for participation in an analog mission? Because in my 43 years, we've discovered a lot of stuff we missed, and we have a lot of toxic chemicals inside of us, about 20,000 to hurt a healthy person, and maybe that we need to be actually doing more low-tech preparation for a mission. What's your opinion?
Yeah, I agree with you. I think that our standards of what kind of health and what kind of fitness level we wanted people to go to Mars has changed. And I think that I'm not an environmental, I don't look at pollutants. I'm not that kind of scientist. I like to be happy. Humans, I only do the happy human stuff. But I mean, I think it's being addressed. I think it's, certainly we have crews that are looking at those kinds of things. So I think that I don't have the expertise to answer that question, but I know that there's people out there working on that.
Thank you.
So I was just wondering if there have been any attempts for commercial partnerships with MDRS, kind of like the Habitat podcast.
Remember, I'm just a simple Luddite. I would welcome that. Welcome it. But no, we haven't. It's not something that's come up.
Hi, David Jednak, CTO from Curtiss-Wright. What are your top 3 technology challenges for increasing the fidelity of the simulation at MDRS? What if you had a wish list, what would be the top 3 things you'd
Wish
make better?
list, because I was going to say money, money, and money. I think one of the things, even a simple thing, so here's an example. We have a crew of doctors that come and train other doctors, and they put an automated timer in the airlock, which we don't have. That cannot be a very expensive fix. And one of the things we're doing is we're starting an innovations program at MDRS where groups can propose things like that. They can say, hey, we can make this thing happen, and we can fund that. We can't fund them at a large rate, but we can, we can partner with a student group or a group of people that just wanted to do that. I think that, did I do something wrong? I'm really good at that. I shouldn't be allowed to touch things. I think part of our problem is we need more bells and whistles, if you were, to increase the fidelity. We need slicker facilities. If you're going to look, and we need more consequences. We need to find some way to put consequences into when things fail. And I don't know how you would do that technology-wise, but there's got to be a way to let mission support know, or the crews themselves know, if somebody breaches an airlock and they weren't supposed to, for example. So for MDRS, it's very, very, I only think operational. So I'm sure other people have tons of technology ideas, but not necessarily. Robert's got technology ideas.
Thank you.
Let's take one more question, and short questions, short answers.
Okay. I don't
Hi.
do short answers. I'll try.
You got it.
Hi, Shannon. My name's Kai Stotz. I was
I'm kidding.
Mars Crew 134, and wanted to thank you for all the good work you've done over the years, and also commend you on one of the slides where you said that MDRS has inspired a lot of people. And in that respect, at the Biosphere 2, we are currently have designed and we are building a fully sealed, completely pressurized analog that'll be hopefully built next year. And so I want to let you know that at the Biosphere 2, we're doing some really, really good work with Arizona State University and the University of Arizona. It won't be the full Biosphere, it'll be a smaller subset. but that's in motion.
I'm
and
excited.
Yes, so I would enjoy, since we don't have time right now, but I would enjoy to have your feedback
Okay.
on how you would like to see, what you see we could do to make that the best experience possible.
Awesome. Thank you.
Thank you.